So chapter 2 is has everything to do with angles and those properties that we're going to use um, to solve various problems. So the calculator will obviously be required from time to time, but we're not going to actually use all of its features until we start graphing, like when we do quadratics and linear. So just keep in mind. So what are we going to do here? We're going to look at parallel lines. Like you're going to see things like that in the homework, right? So there are parallel lines and a line that cuts through it, and you have to find all those missing angles that are in there. Don't write in these books, okay? I have a beat up textbook, so I get to do that. And some of the things are going to be new. Some of the things you will have seen already before. So that's what we're doing at first. So just getting used to terminology and what do we call these angles? Like we need to have a name for them. We can't just say that one, right? And so we're going to do that. We also will then end up with like a lot of like lines going every which way. You're going to see some triangles inside the lines that are created, rectangles, polygons, all of those we kind of build until we get to polygons. Polygons are like your pentagon, hexagon, anything gone, right? Your mind will be gone, right? Anyway, so we're going to do a lot of those at the end. So that's kind of how we end this unit. So I just like to give you a heads up. That's where we're headed. That's why I need to review some of these terms, okay? So get to your booklet, have a highlighter or two ready to go. Because it's yellow, I'm going to use maybe orange and green to highlight things. I have ordered a whole bunch of stuff ready before, so the yellow is not a good idea. I'm not going to do it anymore. Okay. Anyway, so types of angles. I'm just going to, for myself, types of angles we have are acute angles, so obviously anything less than 90, right? Anything less than 90 degrees is defined as acute. Obtuse, as soon as it's bigger than 90, right? We call that obtuse. Greater than 90 degrees. Right angle, that is very specifically, and all we do is we put a box right where those lines meet. It's a 90-degree angle, right? Exactly 90. Straight angle is when, let's pretend like this point right here is where those two lines started, right? So you have one going straight left, one going straight right. The angle formed between those two is 180 degrees. So we call it a straight angle. And then your reflex, maybe, you know what? Sorry, I know you're gonna be. So let's pretend I'm gonna copy one of these here. So let's pretend I'm copying that obtuse angle. So this would be obtuse in here, but if you consider what's on the outside here and put a dot right there, okay, just as a reference at where they both started, that's greater than 180. Anything greater than 180 degrees would be called a reflex angle. So there you have your angles all summarized. And the following properties are always true. And I'm going to build on this. Like I know you're going to look at these and like, Mr. Dirks, I know that already. I've heard it since grade 8, right? But you'll be surprised how many students don't see that when there's a bunch of lines going every which way, right? So complementary is angles whose sum is 90 degrees, okay? A way to remember is it's right to complement someone. It's right, 90 degrees to complement. So there's because sometimes students mix complementary and supplementary up. So just that's a little way to remember. So if this is 20, then angle Y we use the notation angle if at all possible. Angle y would be 90 degrees minus the 20. And so we have 70 degrees as the y. And those two combined would be called complementary. I think what the misconception is that complementary angles are always two angles that add up to 90, and the truth is no, it could be multiple angles. If they all add up to 90, they are collectively complementary. Supplementary angles whose sum is 180 degrees. The shortcut for us is this. I'm going to say straight angle is 180 degrees because we're going to use this one quite a bit. So for instance, if I tell you that this is 150, you should recognize that there's a straight line right here. Emphasis on that straight line, right? And so therefore, you should right away know that this angle on this side would be 30 degrees. And it just goes like 180 minus 150, right? They add up to 180. Next, so let's say you have something like this going on, you're like, I don't know what to do. Focus in on the straight line, okay? The straight line is right there, so along that straight line, any angle formed along it, right, all of those must add up to 180. So angle X, in this case, is 180. Where did I get that from? I got that from the straight line. 180 minus 31 minus 24, and I end up with angle X being 125 degrees. Okay. So far, I think that's all review. Vertically opposite angles, okay, are congruent. Okay, vertically opposite angles are congruent, and that's the same as equal. Okay, and what's the shortcut for that one? I will say this: vertically opposite angles, right? This is the symbol for congruency, meaning they're the same. It's an equal sign with a third wave on top of it. Uh-oh, that reminded you of COVID, right? The third wave. There were always waves coming, right? So shortcuts, vertically opposite angles, right, are congruent. That's what I call that. And so in this case, when two lines meet like this, let's put a dot right there at the center. This angle right here would be vertically opposite to that one right there. So let's call this X and Y, okay? So angle X is going to be exactly the same as angle Y. And why is that? Because vertically opposite angles are congruent. Okay, so that's my explanation as to why I say that. By the way, guys, these two here would also be vertically opposite. I'm just not going to label them. Okay, but there's two sets of vertically opposite. And you might not believe me, so I knew you're not going to believe me, so I just quickly went into GeoGebra. Do you remember? Anybody ever heard of GeoGebra? Yeah, some of your teachers may have used it. It's a really cool little app, but basically, I just created two segments. And look at, I know the angles are pretty crazy, right? They're using a lot of decimals, but the point is still being made that this angle right here and that angle, they are exactly the same no matter what I do. Okay? It stays the same, right? So if two lines intersect, the angles opposite to each other will be the same. Okay? So now you believe me, right? Of course you do. Can't argue with GeoGebra. Anyway, so then when you have, whoa, what's happening here? There's too much happening here, Mr. Joyson. I can't handle that, right? What I want you to do is, for example, follow one of the lines like that, and then follow another line. And then focus on those two lines only right now. You could now see the two that are vertically opposite, correct? You see them? Okay. All right. So we know that y is going to be equal to 29 degrees, right? Vertically opposite. What is x going to be? 35, right? So I hope this isn't going to make it worse, but I'm using a different highlighter to just see. I'm going to follow these two lines, right? And these are vertically opposite. So that's 35 right there. And what about Z? We just learned another property which you need to insert here. Supplementary. You see what Jalen, right? What Jalen did most likely is he followed this straight line here. And along that straight line, we have 1, 2, 3 angles. You see that? Watch this. You see that these 3 angles are along that one straight line? Ooh, that made it worse, didn't it? It looked really good on my paper. Anyways, Z, right, angle Z, I'm just going to go 180 minus 29 minus 35. I'm going to subtract these two from 180, and the remaining amount has to go to Z. Does that make sense? Okay. Angle Z is 116 degrees. And I will say that, how did I find this? Straight angle is equal to 180. Because I'm going to ask you to explain why is that. Angle Y is 29 degrees. How did you find that? Vertically opposite angles are congruent. Angle X is 35 degrees. Why is that? I used the vertically opposite angles being congruent property for that. Okay, so don't use pink anymore. Got it. But you can still see, yeah, you can still see. All right. Next, sum of interior angles of a triangle is equal to, all angles in a triangle add up to 180 every single time. All angles in a triangle add up to 180 degrees. Could it have been 90? What about a right triangle? If you have a right triangle, what's one of the angles? 90. So what about the other two, right? You're stuck. Right? It has to be more than 90. So 180 degrees. Shortcut, this is you're going to like this one. Sum of triangle is equal to 180 as the shortcut. And so how's that helpful? Let's draw a triangle here. And we'll make this 30 degrees. We'll call this angle A, lowercase, and 70. Let me just move that up a little bit for back row folks there. So there's my triangle. I know 2 out of the 3. You should immediately be able to find the third. Okay, A is equal to angle A, that is. I will go 180 minus 30 minus 70. And you're like, Mr. Dixon, isn't that exactly the same as straight angle? Kind of, right? Like it looks exactly the same, but you're using a different property here. This is 100, so 100 take away from 180, that's 100 degrees. No, it's 80. Sorry, guys. I'm too excited for the weekend already. There you go. And I use the sum of triangles equal to 180. If I ever ask you to explain, that will do it. That right there will do it. You don't have to write sentences, just use the shortcut. And if you forget the shortcut, it's okay. Use your own words. All right? It's not a big deal. Shortcuts are there to help you. Okay? Next, sum of interior angles of a quadrilateral. What does that mean? How many sides when it's a quadrilateral? 4. Quad, right? 4 sides is equal to a square has 4 90-degree angles, right? So 4 times 90, 360. It's always 360. It doesn't matter if you now slant it or whatever, it's always going to be 360. Okay. Okay. And so let's make a 4-sided. I'm not going to make it look like a square. Okay. That's a 4-sided. That's a quadrilateral. Anything that's 4-sided is a quadrilateral. So let's say you have 80, 55, 85, and you have angle B down here. Convention, guys, if I can refer to it as angle lowercase b if I write it inside the shape. If it's outside the shape, we usually use capitals. I didn't make this up, right? You can't blame me. So angle B will be 360 minus 80 minus 55 minus 85. So I just subtract the 3 that I have, and that is, so this will be 90, 140, and 80, 220. Yeah, so that's 140 degrees right there. And I used sum of a rectangle or a 4-sided is 360. I didn't give you the shortcut, did I? Here's the shortcut. Sum of a 4-sided shape is the angles add up to 360. Maybe I'll box in all the shortcuts. I go all the way up there and I box in all my shortcuts. Shortcuts are very helpful. So far, all review technically. Even if you forgot, I'm glad that now you know. But these are just things that technically you already need to know moving in. Okay, flip over to the next page. How's that? Okay, diving right in now. And this is going to be a very classic setup. For sanity's sake, for my sanity, I will give you a little chart, and that's where you put it in. Okay? Otherwise, I lose sleep. Okay? If I lose sleep, you're in bad shape, right? Like it's not going to be easy to mark. So this is what I'm asking you to do. There is quite often more than one way to solve these things. That's just how these works. Like some of you will start up here and you'll move this way along the shape. Some of you will start at the bottom and move up. So it doesn't matter to me. That doesn't matter. I would like you to just tell me, where do you start? Where did you start? Because that makes it a lot easier for me to mark. So, for example, it just happens to be the case, but do you see the triangle? I love identifying triangles that have 2 angles already given. That's my go-to. So my first step is going to be to find that angle up there. So I will say, okay, that's where I start. That's my first step. And if you know what, this unit will be very good to have a highlighter. Okay, maybe even just to get you started. So I will justification work reasoning is where you just obviously you show me the work. So you go 180 minus 60 minus 70, and that is 50 degrees. So that's the work, and I will write that into the angle column there. Make sure you have your degree symbols there. And I will just quickly use the shortcut to explain my reasoning, and that's the one I've used. Quite often, you'll be able to use it more than once, but sometimes I will make you use different ones. So I'll force you to use a different property for every single line. Okay, next, which one would we do next? I know that Y I can do, but I'm going to skip. I'm going to say, let's try to find M next. So that's going to be my second go-to. What could you use to figure out M? Do you perhaps maybe see a straight line anywhere? You see it? You see that straight line there? And there are how many angles along that straight line? There are two, right? If you follow that straight line, you have two angles. And when it's along a straight line, you know what to do. 180 minus the 45. And what do I get? That's 135. Oh, sorry. Thank you. Over here, guys. My bad. I'm just checking if you're paying attention. It's very important to pay attention. I wish I could say that. All right, so 135. And I will just say that that is the straight angle is equal to 80 degrees, sorry. And I just put the 135 in there. And some students like to actually put the number here as well. If that helps you, go for it. Which one should we do next? It doesn't really matter. I will do Z here. That's my third go-to. What could you use to figure out Z? Like, do you remember that property? Vertically opposite, do you remember that? Because if you follow these two lines, if you put a dot there, maybe that helps you. These are opposite each other, right? So Z is automatically 85. You just say vertically opposite angles are congruent. That's it. It's like you're talking code language, right? And then the last one is Y. What would you use in that case? You can use a straight line again. That orange line is straight, and these two are there, right, along that straight line. So we can do that. So we're going to go 180 minus 85. That's 95 degrees. Straight angle is equal to 180. Boom. You just solved that, all the angles in this triangle. Could there have been a different way? Absolutely. And maybe don't write this down, just watch what I'm doing. I'm just going to say that this is 135, right? We figured that out. Would you agree with me if I put 135 in here? Vertically opposite. What shape is inside here now? A quad, right? A quadrilateral. You see this four-sided shape in here? I know 3 out of the 4, right? I know that I could have used 360 minus 60 minus 70 minus 135, right? And get to the same answer, and then I would just go sum of a four-sided shape is 360. Okay, so it can be done. You just have to be a bit creative. So always remember, zoom in. Sometimes students zoom in too quick, zoom out. It's like, oh yeah, I see that, and then zoom back in, right? Okay, let's keep going here. Parallel and transversal lines. This is a very important concept. Parallel lines, 2 or more lines. There's a typo there. Oh, sorry. No, 2 or more lines are parallel if they never meet or intersect. Okay, they never meet or intersect. You can recognize parallel lines when the symbol in the form of an arrowhead is visible, right? Symbol of an arrowhead is on 2 or more lines. So I will say that you got to be careful here, but this line would be parallel to that line, and I'm going to use a green one here. This line is parallel to that line. So you have 2 sets of parallel lines here. So what we can say this, AB, so AB, this segment here, is parallel to CD, segment CD. Okay, and the notation we use to make reference to that is AB is parallel to CD. Also, right, EF is going to be parallel to GH. And if lines are not parallel, you would simply cross that. You would have like a line crossing like that. You'll see more of that as we move on. Okay. Transversal, a line that intersects, right? A line that intersects 2 or more lines at distinct points. Okay. A transversal line can also be a parallel line to another line. Just keep that in mind. When a line is referred to as a transversal, we know that along it, we can find 4 distinct pairs of angles. Okay, I will make sure I make reference. Like that is very important. That statement right there. And pink doesn't seem to do it here, so I'll do orange. When a line is referred to as a transversal, we know that along it, we can find 4 distinct pairs of angles. And in this particular case here, when you look at this diagram, this would be the only transversal present in this case. Okay, so transversal. Before I move on, let's see if you can follow this thought. These 2 lines here are parallel to each other, correct? But if I were to just zoom into this line, would that be considered a transversal? Just this line? The answer is yes, because it cuts 2 or more lines at distinct points, right? Same if you were to zoom into this one, just on its own, it is a transversal because it cuts 2 or more lines, okay? So yes, they're parallel to each other, but individually, they are transversals as well, okay? Right, you gotta shake that off. It'll make more sense later on, okay? Next. So this is where you are lucky to have a booklet. Okay, you don't have to sketch these things a bunch of times. So let's go over to page 3. So here are the 4 distinct angle pairs. You need to know these names. Okay. So the first that I'm going to talk about is the corresponding angles. I'm often going to just refer to them as CA. Okay, corresponding angles. And let's make something clear first of all. If this is your transversal, right? If this is the transversal, then this inside here will be referred to as the interior, and then everything outside of the sandwich. Pretend like these are the buns or whatever, right? And so everything inside that is called interior. Therefore, everything outside is called exterior. And if you have 2 different colors, or at least 2 different highlighters, that'd be great. I will give you the first pair of corresponding angles. This is the first pair. This angle corresponds to this angle right there. Also, the next set, I would say that this angle corresponds to that angle right there. The same happens on the other side. So 2 would correspond to 6, 3 would correspond to 7. Okay, so this is the definition. On the same side of transversal, on the same side of transversal, one interior and one exterior. So these are kind of the conditions that need to be met for angles to be called corresponding. Follow my line of, right? So if this is a transversal, you need to be positioned on the same side of the transversal. In this case, one is inside, one is inside, one is outside, right? One interior, one exterior. So 1 and 5 are therefore corresponding. So 4 pairs of CAs, right? And so it would be angle 1 and angle 5, angle 4 and angle 8. And on the other side of the transversal, it would be angle 2 and angle 6, angle 3 and angle 7. Okay, so these are my 4 pairs of angles. So they have a name, and that I need you to be able to tell me. It's like, hey, list all the pairs of corresponding angles. You should be able to do it. Okay. The next ones are alternate interior angles, right? So I call them AI. Okay. And if you can add this, the word alternate is basically telling you opposite side of transversal. Opposite side of transversal. That's what you need to remember. So let's see if you can also get the pattern. They're both interior, right? That is a must. So you have to stay on this side. So it would be 4 and 6, as well as 3 and 5. Yes. Uh-huh. So I'm just going to write down interior, right? We are focusing on the interior only. So those two would be alternate interior, and you form an X basically, right? If you want to look at it that way. Two pairs, angle 4 and angle 6, angle 3 and angle 5. That's it. Okay, we're good. Next, we have alternate exterior. So A, E, right? Alternate exterior angles. You recognize that word alternate, right? Opposite sides of the transversal. You recognize the word exterior, correct? Exterior would be outside of the, let's put a little, right? Make sure we know that this is a transversal here. This is the transversal, and along it, we find these angles. So it would be 1 and 7, as well as 2 and 8. Angle 1 and angle 7, angle 2 and angle 8. So obviously everything is on the exterior, and the word alternate tells you basically to alternate, right? Like to go one inside, one is on the left, one is on the right. So they're opposite side of the transversal. And the last one, consecutive interior, CI, right? Oh, that actually would be CIA would be pretty good, right? So let's do that. Yeah, that will catch, right? You'll remember that. CIA is right there. So consecutive interior angles would be 4 and 5, as well as 3 and 6. Consecutive means one after the other. Consecutive, right? So these are consecutive interior, these are consecutive interiors. Two pairs. Angle 4 and angle 5 would be considered consecutive interior. Angle 3 and angle 6 would also be considered consecutive interior. So corresponding is about it, okay? I just want you to not get stuck on this part right here, watch. We're so used to right now, oh, it's always just up and down, right? I could, right? You could be given a diagram like that, right? You still have to be like consecutive interior. Okay, well, these are my buns, right? So this is the inside. This is the transversal. That's where it's going to be found along. So consecutive interior would be these two and these two, right? Same here. Alternate exterior, like these are, right? This is the bread. So exterior, exterior, right? This is my transversal. So alternate exterior would be like that, right? It's not always going to be up and down. Sometimes you're going to have to go sideways. Okay. So don't get too hung up on that. Okay, let's keep going to the next page here. Angles formed by parallel lines. This is very, very important. This is basically the meat and potatoes of today's lesson, okay? Watch what I'm saying. So I just introduced you to the names, but there's something that is true about these angles that I just talked about when the following is true. When a transversal intersects lines that are parallel, then all of the following are true. Okay? When lines are parallel, all of the following are true. Okay? Alternate exterior angles are congruent. So you can say alternate exterior angles are congruent. Shortcut. Alternate interior angles are congruent. Corresponding angles are congruent. No. Yeah, corresponding angles are congruent. Angles are congruent. And the consecutive interior angles are congruent. Oh, wait. Supplementary. So that's the one you need to remember. CIAs, right? Add up to 180 degrees. Supplementary, right? It's on. So if lines are parallel, then that is going to be true. On the other hand, and I will give you a nice graphic representation underneath this so you remember. On the other hand, watch this. If you can show that one of the following is true, right? All you need to do is tell me that one of them is true, alternate exterior congruent, or this is congruent, or this is congruent, or consecutive interior angles are supplementary, then lines connected by the transversal are parallel. And you're like, hold it. What is happening here? Okay. So this is what's happening. This box right here is saying the following. You can go arrow down. There's 4 check boxes that you're always going to think about. Okay. Another checkbox is that alternate interior angles are congruent. The other checkbox is corresponding angles are congruent. And the 4th checkbox is CIAs add up to 180. So you are going to approach this problem. The question will be, hey, look at this diagram. Do you think the lines are parallel? Your task will be to put a check mark on one of these. You're not going to pursue all of them, just one of them. Because if one of them is true, it turns out that all of them are true. Okay? Then, right, so if this is true, if one of them is true, then lines are parallel. That's what that second box is saying. And the first box up here, I'm going to go from all the way up there and just go arrow down like this. The first box is saying if lines are parallel, okay, then AEs are congruent, AIs are congruent, CAs are congruent, CIAs add up to 180. You actually check. You can make a check box and say that all of them are true, Mr. Dirksen. I know it. That's a fact, right? So if I'm told that this is true, boom, I can assume all of this is true. On the other hand, if I'm asking you, hey, are the lines parallel? You check off one of these boxes, then that will be true. Yeah. And I know you're gonna, right now, it's too much theory. You cannot wrap your head around it. Just trust me, once we do examples, you will be in better shape. How are you doing? Hope your brain isn't hurting too much. I need to put a little break here and just talk about notation, okay? So if I want to refer to this angle right here, can I just say angle D? Angle D, is that correct? No. How many angles are right here at this point? There's one here and one there, correct? And technically you can argue there's a third on the outside. So if I want to refer to this angle in particular, I need to use the three-letter notation. So how will I do this? Yeah, I will say to refer to that angle, you can go angle A, D, B, or you can refer to it as angle B, D, A. You remember that? Please tell me you remember at some point. Yeah. Otherwise, I would go talk to your grade 10 teachers, grade 9 teachers. Okay. But this is the beauty, and this is where I'm okay with you doing that. If you say, no, that's too confusing, Mr. Dirksen, I don't like that. If you say, right, that angle right there, I'm going to call that angle X, and then you come in here and call that angle X, I'm okay with that. So from now on, you don't want to be using the three-letter notation anymore. You just want to give it a letter, A, B, C, D, X, Y, Z, whatever you want. We usually use lowercase and just put it in there. And now you know this is the angle that I'm talking about. But you're going to have to read this and know where is it on my diagram. Okay? Can I call this angle C here, this one? Yeah, I'm okay with that. That's angle C right here. Okay? Angle C is that one right there. You could do DCB if you want, or BCD, that's fine. But if it's only one angle, then it's okay for us to do that. Okay? So just give it a letter. So connect these two. It's like I'm going to use X from now on. Okay? Next. Let's do some math here. Let's actually apply what we've just learned. Take a little break. I'll do a 1 minute break. Stretch. In each diagram, prove or show whether or not EF is parallel to GH. Is there more than one way of justifying? And the answer is yes. Prove or show whether or not EF is parallel to GH. So is this in fact parallel to that? You can't just say yes or no, right? There's a 50-50 chance. You have to show. What are we doing when it's a question like this? Let's go back just 1 second here to the back side. Are you doing this, or are you asked to do this? In this case, they're asking you if lines are parallel, so they're asking you to verify that one of these is true. One of these is true. Okay, so let's go back, and I think I'll give you steps here to help you out. I made a little note for myself. I think I'll say this: try to find an angle pair with a name. Because let's face it, there's lots of angle pairs, but you want one that you have a name for, specifically the four we just talked about. Some work maybe, right? Some work might be necessary. You might have to do a little bit of work and using, the things that I told you are always true, the first page. Sum of a triangle is 180, sum of a rectangle is 360, straight angle is 180, all those things. Those are facts. You cannot use those to prove if lines are parallel. You have to use this for to make that point, okay? So second, check to see if the property is true. So you're either going to have to ask yourself, is it congruent or is it equal to 180? The only one that is equal to 180 is the CIA, right? And then you're done. And then you've made, then it's just a matter of stating the obvious, okay? So let's do our work here. I will just make a capital T for transversal. This is obviously my transversal. And the angles that I'm looking for are along that transversal. Do you see at least one pair that we have a name for? What do we call these two here? You can check, that's fine. Ready? Corresponding angles, that's right. So I will say this. Corresponding angles, right, are what? Congruent, and that's exactly what I want them to be, correct? Therefore, EF is parallel to GH. That's as easy. This is one of the easiest ones, okay? I will just do this for our notes, okay, that I've used corresponding angles there. But that's not the only way to make that point. Do you see another pair? Yeah. Alternate exterior, right? They're definite alternate, and they're both on the outside. They're definitely alternate exterior. So you can say, or, don't do this on a test. On a test, just stick with one, right? You could say that alternate exterior angles are also congruent. Therefore, EF is parallel to GH. Done. So you name it. Okay, you name it. And in this case, there was zero work required to come up with some numbers that would make you connect the dots. This is a straightforward one-shot kind of deal. I will cut this. I will cut this right here. Okay. Actually, right across maybe. Second question. Do you have a pair that you have a name for? Alternate, right? They definitely look like alternate, don't they? But alternate interior, we would need these two, right? Alternate exterior, we would need this one and that one. So we technically don't have a name for these two. So I'll put that down. Don't have a name for the pair. You might have more than a pair, but for this particular, we don't have a name. So let's do a little bit of work. I will introduce a variable maybe. I'll call this angle X. So my first step is going to be angle X is, how would I find that? What is this? Straight line, right? Also known as a transversal in this case. So it's just 180 minus 70. That's 110 degrees. Let's write it in there. Why not? What do we call those two? Alternate interior. Yes. So alternate interior angles, is this true? Are they congruent? Just look at the numbers. 110 is not congruent. It's not the same as 19, so you do one of these. Alternate interior angles are not congruent. Therefore, EF is not parallel to GH. And you're like, Mr. Dixon, I don't have to show the corresponding, I don't have to show all of the other ones. Nope. As soon as one of them fails, everything comes crashing down. Same the other way. If one of them is true, everything is true. And so you can conclude that they are parallel. Question, could I have done this differently? The answer is yes. So here it is. Because this is what throws students off. They look at my key and they're like, but I didn't do it the way you did it. Yeah. Go ahead. And that's fine. So here's the other way. Let's call this y. So pretend like this isn't there, right? The x is equal to 110 is not there. I just start from scratch. What's y equal to? What are these two? Way at the beginning. Vertically opposite. So vertically opposite angles are always equal, right? So you just say vertically opposite angles are congruent. But that's not enough for us to make our point whether or not lines are parallel. This is just always true, right? So you put 70 down here. What are these two angles called? Consecutive interior, yes. So this is how I'm going to do it. 70 plus 109 is 179, correct? Consecutive interior angles do not add up to 180. They're not supplementary. You notice that, right? You can obviously see that. What do we want them to add up? We want them to add up to 180. It's not happening. Therefore, you make the same conclusion. Okay, so those are your two ways of coming up with the answer. And I'm going to step it up a notch here. I just want to double check here. Yeah, okay. So there's something like this in the work that I'm going to give you. Okay. Whoa, this is a lot, right? I want to, the question is whether these two lines are parallel, right? That's the question. So I'm going to focus on trying to see here how can I explain this to you so you basically, do you see triangles? You see them, right? There's a big one here, there's a small one there. So keep that in mind when you do these. Straight lines, triangles are almost always your entry. Okay? So what I'm going to do is I'm going to focus on this triangle here. Why is that? Because 40 and 75, I've got 2 out of the 3. And why am I so interested in this angle right here? Well, first of all, sometimes just do it. Just figure out angles and put them in, right? Start somewhere and figure out the rest. What are these two angles called? Along the transversal, right? What are these two called? Look it up. Yeah, I want you to look it up. There's transversal 1 here. There's transversal 2 there. Alternate interior. Yes, I have a name for them. Alternate interior. You're like, Mr. Erson, but these two transversals, they touch up there. That's kind of messing me up, right? It's going to happen more and more. It's there to make you do some extra work to get to your final answer. So watch this. I will first figure out what angle X is. I'm going to go 180 minus 75 minus 40. And that gives me 65 degrees. Oh, I like what I'm seeing, right? You're probably going to be like, yep, I like that, right? Because I see 65 there, 65 there, probably parallel. What did I use here? If I ask you to explain, okay, sum of triangle is equal to 180. Try to show me as much as possible when you do these. So I've got that. You cannot say yet that they're parallel. You have to now name them. Okay. Alternate interior angles are congruent. 65 degrees if you want to put it that way. Therefore, EF is parallel to GH. Okay. Therefore, EF is parallel to GH. You could now go into the diagram here and introduce arrowheads. You could actually say, hey, I can finish this graph and from now on say, hey, those lines are parallel no matter what happens. Okay, they're kind of it's a fact. So you could add more transversals cutting through it. Those two lines are still parallel, right? I'm trying to think here. I think I'm just going to leave it like that. We've done enough damage, right? Next. This will be the last one, okay? What could you do here? Figure out names, sorry. Do you notice these two here? What do we call those two? Right next, they're right after each other, so they are consecutive. Consecutive interior. So I'm going to do 83 plus 97 is equal to 180. I'm just going to do a quick check, right? Therefore, so I'm going to say that consecutive interior angles are equal to 180, which is exactly what I want. Have that on your study sheet. Therefore, I can conclude, right? And remember, this is the transversal along which these angles are found, right? So we can call this T1 and T2 because, yes, there are two transversals in there. This is very important. EF is parallel to GH. One more. Okay, true or false? Lines are parallel no matter what, right? We've established that these two are parallel. We've done the work, correct? Would it matter if I went over to this transversal? Do you think I should get a different answer all of a sudden? No. But I will show you that you could have used this transversal to make the same conclusion. Because you need to be able to do that, right? So here, this is the grand finale. I'm going to do a little bit of work. How will I do this? I will find this one here. What? Yeah, I will do. X is equal to 180 minus 77. That's 103. How did I find that? What property did I use? Straight angle is 180. Would you agree with that? There's a straight line here. So now I know that this is 103. Do you see another 103? Right up there, what do we call those two? Same side of the transversal, so it's not any of the alternates. Corresponding. Okay. Corresponding angles are congruent and they're both 103. Therefore, surprise, surprise, right? Not really, right? It's still true. I could draw a million transversals on these two parallel lines. You have to come to the same conclusion because they're not changing, right? So the homework, here we go. Homework, page 16 in the workbook. Sorry, it's a little bit all over the place, the workbook, I agree. That's going to be a bit too challenging. I think you haven't seen enough. So I'm going to switch it up. I'm going to tell you to go pages 6 to 7. Pages 6 to 7. In the workbook, that is, workbook, not textbook. Thank you.